Rust, those little reddish-brown pieces that appear and flake off a metal over time. We've all seen it, know what it is, and especially know that it's annoying. But what exactly is it? It slowly takes over our metal possessions and even big things like cars and bridges. But why and how? Most people have a general knowledge that when you spill water on metal, it'll rust, and yeah, that's slightly right. You see, only metals that contain iron will rust. This means that only iron metal or iron alloys, which are metals that contain a mix of iron and other metals, will suffer the process of rusting. The production of rust is a redox reaction, a chemical reaction involving the transfer of electrons between two species. Rusting needs just three things: iron, oxygen, that's usually from the air, and water. It can be in liquid or gas form from air moisture. Redox splits into two words: reduction, which is when a reactant gains electrons during a reaction, and oxidation, which is when a reactant loses electrons during a reaction. Now, just a few more definitions. The anode is where oxidation occurs, and the cathode is where reduction occurs. The electrolyte solution in our redox reaction is the liquid that helps electrons move between the anode and the cathode. The chemical formula of rust is iron 3 hydroxide. We can get this from the reactants of iron, oxygen, and water. Throw some coefficients in there, and we have our balanced equation for rust. Now, let's dig into the process of rusting. If we take a look at this diagram, the surface of the iron in the middle of the water is the anode, the electrode where iron oxidizes. This means that iron is a reducing agent. The balanced oxidation half reaction is Fe, forward reaction, Fe 2 plus charge, plus 2 electrons. And with an oxidation reaction must also come a reduction reaction. The electrons lost by the iron move through the electrolyte, which is the water, to the edge of the droplet on the iron surface, and this part is the cathode, the electrode where oxygen reduces, which means that oxygen is the oxidizing agent. The balanced reaction half reaction is O2 plus 2 H2O plus 4 electrons, forward reaction, 4 OH. The electrons react with water and dissolved oxygen to form hydroxide. Multiplying the oxidation reaction by 2 to even out the electrons, and canceling out the electrons, we end up with an overall equation of 2Fe plus 2H2O plus O2, forward reaction 2Fe2 plus 4OH negative. Let's also keep in mind that water dissociates into hydrogen and hydroxide. With the Fe2 plus that we got from the first oxidation reaction, we can add hydrogen from the water and dissolve oxygen to get this equation. But exactly how did we get here? We can break this apart and look at the oxidation and reduction equations. With Fe2 plus going to Fe3 plus, we can add an electron to the product side to balance the equation. For the second equation, from O2 plus 4H plus with a total of 4 plus charge going to 2H2O, we can add 4 electrons to the reactant side to balance it out. Now, to add these two together, we need to multiply the first reaction by 4 to obtain 4 electrons. Now cancel those electrons out and we get this equation. Now, one last step. The Fe3 plus obtained from that reaction will combine with hydroxide ions that came from the water or first reduction equation and make Fe bracket OH bracket 3, our beloved rust. Now that we know how rust is formed, let's look at how it affects our daily lives. Many things in our daily lives used to run this world are made of iron, and that's not such a great thing. From small tools to huge bridges, these things are almost guaranteed to rust. And let's get this clear. Unless you're looking for some reddish-brown metal confetti, there's virtually no pros to rust. It may not seem like such a big deal at first, but eventually the costs add up. Rusting objects means that they'll have to be constantly replaced, which means spending money. Not only does it cost a fortune, but it also becomes dangerous. When transportation systems like bridges rust, it damages their structural integrity and makes them less flexible, meaning that they are unsatisfactory in windy conditions. This means that checkups are mandatory to ensure that it is still safe for use. The fact that with given enough time, entire structures will rust means that these million-dollar structures will have to be replaced. This is clearly not good for the economy. It only slows down the development of our society. For example, in 2018, the US Pentagon stated that they spend an estimated $21 billion a year to combat rust. That's because things like Navy ships and Air Force jets will rust the more that they are exposed to the harsh environments and need replacing. This means that we're spending an insane amount of money on a natural chemical reaction that could be going towards infrastructures, citizens, and helping the economy instead. Furthermore, the rust that flakes off can be carried by the wind into our waters, plants, and ecosystems. Now, how can we prevent rust? Well, the most straightforward option would be to stop making things out of iron, but that's nearly impossible. As individuals, we can try to use products that apply rust-preventing coats on our things, but it's not a permanent solution. It'll eventually wear off and have to be reapplied. Storing iron belongings in dry, airtight conditions will also help. Now, these may be easy fixes for our small objects, but what about things like bridges and those huge ship chains that go in the water? I suppose they could apply rust-preventing coats on them, but they'll eventually wear and wash off over time. And reapplying is definitely a tedious task. Well, there really is no way to prevent rust on these things. We're forced to continue having to replace these things that are caught in this natural chemical reaction, and we'll have to continue buying and replacing things. But hey, at least we know the chemistry of it, right?